Similarly to how we did example 1, the very first thing that we want to do is take a look at our problem and see what clues it gives us. So if we read this out, it tells us that the population of small town in the year of 1890 was 6,250 people. Since then, it has increased at a rate of 3.75% each year. What was the population of small town in the year 1915? And again, we're looking for some clues. And since I see this word increased, that clues me into the fact that we are now talking about exponential growth. And when we talk exponential growth, that tells us that our formula is f of t equals a times 1 plus r to the t power, where a is your initial value and r is your rate. So after we've identified if we're talking growth or decay, we want to be able to write this function. So we need to figure out our initial value and also our rate. And so our a value, our initial value, is the number of people that small town had to start off with. And in this particular case, we start with 6,250 people. Okay. And after we've identified our number of people we start out with, we want to figure out our rate, how fast small town is growing. And it tells us that we are growing by a rate of 3.75%. But remember, 3.75% doesn't really help us out a whole lot until it's been turned into a decimal. So after we move this decimal place to the left 2 places, we find that 3.75% is equal to 0.0375. So now that we have our A and our R values, we can do a little bit of plugging in. So f of t is going to be equal to our initial value of 6,250 times 1 plus, this time instead of minus, because we're growing, 1 plus our rate of 0.0375. And then this is going to be to the power of t. And this represents our exponential growth function, but we want to simplify that inside parentheses just a little bit more to find that f of t is equal to 6,250 times 1.0375 to the t. I added those two numbers together. Now, in our last problem, the t was given to us pretty directly. We were able to identify our time. This time, we have to use a little bit of the context clues in order to figure out how many years we're looking at. And so we're told that they first took the census. They figured out how many people were in small town in 1890. Okay, so if I write over here, you can hopefully see this. So we have 1890. But we also have this other number. We want to know in 1915. So we need to figure out how many years took place between 1915 and 1890. So we're going to subtract those two numbers. And 1915 minus 1890 is equal to 25. So we want to know what the population is 25 years after small town started experiencing this growth. So we're going to plug in 25 for t. And remember, this 25 is to the power of t, not times 25. So when we figure out what f of 25 equals, I forgot to write that, sorry. What f of 25 equals, you see that it is equal to 15,688.54. But we're talking people, so it doesn't make sense that we have 54 hundredths of a person. You can't just have half a person walking around small town. So we need to make sure that this number represents the situation. So in 1915, small town had about, and we're going to round this number to be 15,689.